Hello everyone, welcome to Bright Engineering. Today we are going to look at mathematical induction. So the interesting fact about mathematical induction is that irrespective of how the question is framed, how difficult you think the question is, you are going to go through just 3 steps. So first of all, step 1 is the testing stage. No matter what the question is, you are going to test it. So you get the left hand side to be equal to the right hand side. If that is true, then you move on to the second stage, and the second stage is the assumption stage. So you just assume that if we insert an unknown variable in whatever question we have, it is going to also be true for all variables. And then the last step is the proving stage. That is where you insert k plus 1 in. So if k is going to be true, then it means that k plus 1 should also be true. So let's look at this particular question. So step 1, which is the testing stage. We have this series of numbers, and we are saying that this is equal to this. So we are going to start with when n is equal to 1. So we are testing this to see if it is true. So when n is equal to 1, we are going to get n squared is equal to n plus 1, 2n plus 1, all over 6. So wherever we see n, we put 1 there. So we are getting 1 squared equal to 1 to bracket 1 plus 1, 2 times 1 plus 1, all over 6. 1 squared is giving us 1. 1 plus 1 is giving us 2. 2 times 1 is 2. 2 times 1 is 2 plus 1 is giving us 3. So we have 2 times 3, which is giving us 6. So we are getting 6 divided by 6. So 1 is equal to 1. So here, we've already tested the question and we know that it is true for all variables. So when we used 1, it means it's true. Please note, it's not always that the testing stage you start with 1, but then preferably it's always advisable you start with 1. In cases where 1 is not advisable, the question will indicate that you should start from a different number. Right? Good. So let's continue. Step 2. I call it the assumption stage. So in this stage, you are just not going to do anything. We are just assuming that something is true for whatever we are solving. So we are going to represent our n by k. So when n is equal to k, we are getting 1 squared plus 2 squared plus 3 squared plus whatever variables or numbers are in here which we don't know, plus k squared is going to give us k into brackets k plus 1, 2 of k plus 1. So 2 of k here and plus 1 here, all over 6. And we are done with stage 2, right? So we just write it like this and then we are done. We don't do any particular thing to it. We just put k wherever we find n. And then the step 3, which is the proving stage, we put k plus 1 wherever we find n. So we are just assuming that because we have a series of numbers like this, 1 squared, 2 squared, 3 squared, plus any variable k squared, if that is true, then it means that the next number that follows should be true. Example, when we have 1 plus 2, and the answer is giving us 3, right? And our rule is saying that 1 plus 2 is greater. Let's say 1 plus 2 is greater than or equal to 2. Truly, when we add this, we are getting 3 is greater than or equal to 2. So it means these are series of numbers. If we are to add a different variable to it and get 1 plus 2 plus 3, this should also be greater or equal to 2. And truly, this is going to give us 6, which is greater than or equal to 2. So that's the same thing we are doing here. So here, if we have series of numbers that says that if we add k to it, we are going to get this. It means that the next number that follows, which is the k plus 1, should also agree and then give us the corresponding value here. Which I hope is understandable. Right. So here, wherever we see k or wherever we see n, we are going to put k plus 1. So we are going to get, for the left hand side, we are getting 1 squared plus 2 squared plus 3 squared plus k squared plus k plus 1 squared for the left hand side. So we are going to solve for the left hand side and solve for the right hand side, and it should give us the same value, right? So let's continue from here. So we know that from the left hand side, all these series sum up to give us this value, right? So here we are just going to substitute everything that we have here for this value, because all these sum up to give us this, right? So we are going to get k plus 1 to bracket 2k plus 1 all over 6 plus what we have here, which is the k plus 1 squared, k plus 1 all squared, right? So here we are going to just expand it. So here we are going to get k squared plus k to bracket 2k plus 1 on 6 plus k squared plus 2k plus 1. That's if we expand k plus 1 squared, right? And here we can just find the LCM for this. So we are going to get, expanding this, we are getting 2k cubed, this times this times this will give us k squared, this times this will give us plus 2k squared, and this times this will give us plus k. And when we want to find the LCM, this 6 will come here to multiply all these. So we are getting plus 6k squared plus 12k plus 6, all divided by 6. So we can just straight away add what we have here, group like terms, and then add them. So we have only one variable for k cubed. So we are going to get 2k cubed plus, for k squared we have k squared, 2k squared, and then 6, right? So we're going to get 9k squared plus, and for the values of k we have k and then 12k, which is giving us 13k plus, we have 6 here, which is giving us 6 divided by 6, and this is our answer. So this is what we had for the left hand side. But then let's see if what we are going to get for the right hand side is going to be the same as what we had here. Then it means that our calculations is right. So on the right hand side, we say wherever we find n, we are going to put k plus 1. So right hand side, so we go back to our original equation and then we put k plus 1 everywhere we find n. So we're going to get k plus 1 into brackets k plus 1 because there is already 1 there. We have 2k plus 1 and then plus 1 again here, all over 6. So we are expanding this, multiplying this, we are getting here to be k plus 2, right? So let's note that. So we are getting k times k, which is k squared, plus k times 2, or k times 1 times 1, which is k plus k, which is going to give us 2k, 1 times k, which is going to give us k, and then 1 times 2, which is going to give us 2. Here we are going to expand this, getting 2k plus 2 plus 1 all over 6, right? So here we are getting k squared plus 2k plus, 2k plus k is going to give us 3k plus 2, and then here we are going to get 2k, 2 plus 1 is going to give us 3, right? All over 6. And now we multiply this, so we are getting k squared times 2k, which is going to give us 2k cubed. We are getting k squared times 3, which is going to give us 3k squared, 3k times this, which is going to give us 6k squared, 3k times 3, which is going to give us 9k, 2 times 2k, 4k, and then 2 times 3, which is going to give us 6, right? Don't forget your denominator, all divided by 6. So we are just adding and then grouping like terms. So we have only one variable for k cubed here, so we are getting 2k cubed plus, for k squared we have 3k squared and 6k squared, so adding it we get 9k squared, right? And for the values for k we have 9 and 4, so we are getting 13k, and the only variable without k is 6, right? Divided by 6. So for the right hand side, this is what we are getting for the right hand side, and for the left hand side too, this was what we had for the left hand side. So we can just compare. So for the values of k cubed, we had 2k cubed here we had 2k cubed. For the squared, we have 9k squared here, we have 9k squared here, we have 13k, we have 13k, we have plus 6, and we have plus 6, and obviously they are all divided by 6. So this is what we have for this particular question. So we've been able to prove that what we have on the left hand side is equal to what we are getting on the right hand side, right? If this video has been particularly helpful, please don't forget to subscribe, share, like, and comment. See you another time.